Students, and welcome back. Today we'll be working on multiplying a monomial with a polynomial. So the first thing that you'll need to know is how to work with exponents, and we're going to take a look at 3 examples in our table here. So the meaning of the expression x to the 4th times x to the 3rd is, first of all, thinking about x to the 4th as your base x being multiplied by itself 4 times. That's what x to the 4th means. And then your base x with an exponent of 3 means that we'll multiply x by itself 3 times. So to simplify this expression, we could simply write our base x and then the total number of x's that we see, 1, 2, 3, 4, 5, 6, 7. So we have x to the 7th power. Now, what we could have done is simply to keep the base and add those exponents. So we could have just added the 4 and the 3 together to get that simplified expression of x to the 7th power. Notice that we do keep the base as you're working on this. So keep your base of x and add those exponents. So we'll look at our second example here. We have x to the 2nd power. So that means that we would have the base x written twice. We have y to the 2nd power. That would be the y written twice. This is multiplied by, notice that it's not adding, multiplied by another x, and then multiplied by a y as your base with an exponent of 3. So here we have 2 different bases, but we can still add the exponents, but we have to keep the individual bases. So we could keep the x, and we have 2 and 1, making x have an exponent of 3. And then we have a base of y, and we have 2 and 3. And so we have a total of 5 y's. So x to the 3rd, y to the 5th. And you can write that without the multiplication dot. You can write it with the multiplication dot. It is understood to be multiplication. And then finally, we have this last example where you have 2x to the 2nd y times a negative x to the 3rd. So we have our base of 2. It also could be called a coefficient. We have our base x, and it has an exponent of 2. And we have our base of y. Now, this is multiplied by a negative. So I'm going to write a negative 1 as our coefficient. And then we have x as our base with an exponent of 3. So we'll write the x 3 times. Now, our 2 coefficients, the 2 and the negative 1, will multiply together. So that will give us negative 2. Then we'll keep our base of x, and we have 2 and 3, so that would be 5, and then we have a y. So negative 2 x to the 5th y. We have a couple of other examples that are monomial expressions to be multiplied together in examples 1 and 2. So we have our 5 and our 3 that are coefficients. And then we have our x's, and we have x to the 2nd multiplied by x to the 5th. So we're going to multiply together the coefficients, 5 times 3, which is 15. And then our x's, we're going to keep the base of x and add together the exponents of 2 and 5 to give us 7. So our final answer, 15x to the 7th power. And then in our second example, we have our coefficients of 3 and -4. Then we have our base of t to the 7th and our base of just t. So our 3 times -4, we'll multiply that together to give us -12. And then we'll keep our base t. We have to the 7th, and we also have to the 1st power. So that's going to be t to the 8th when we add those exponents. So -12 t to the 8th power. And that's how you would multiply monomial expressions. Notice that you keep the bases and that you add the exponents. And now we'll move on from here to multiply a monomial times a polynomial. So as I scroll on up, we'll look at example number 3. So in example 3, you have the monomial factor of -4x squared being multiplied into the polynomial. So we'll use the distributive property, as you can see by the arrows. So I'm taking -4x to the 2nd, and I am going to multiply that by the first term of 3x to the 2nd. And then I'm going to put a plus sign between every term. So now I'm going to go back, and we'll take -4x to the 2nd, and we will multiply that by positive 25x. Then we're going to put a plus sign, and we'll go back to our -4x to the 2nd and multiply that by -7. So notice that my polynomial had 3 terms, and so I should have 3 terms in my final answer. Terms are separated by either addition or subtraction signs. So now we'll multiply. We have our coefficients, -4 and 3, that multiply together. That's -12. And then we'll keep our x and add our exponents to get x to the 4th. We'll add to that. Now we're going to do -4 times positive 25. Now at this point, since you're taking a negative times a positive, you can go ahead and make that negative. 4 times 25 is -100. And then you have your x, and we have a 2, and we have a 1 that's understood. So we'll have x to the 3rd. And then plus, we're taking a negative times a negative, so it will be positive 28. And then we have our x to the 2nd power. And notice that I cannot add any of these 3 terms that I've written in blue together because they have different exponents. So adding and subtracting, you have to have like terms, like variables, like exponents. So on your last step, if they don't have like terms, then your final answer will have individual terms. Number 4, it's a little unclear what we're asking you to do, but we're actually asking you to find the area of this rectangle. And so we can think of this as one big rectangle where the top, if we add together those pieces, this could be the length. And then we'll multiply that by this width, and that would give us the area of this rectangle. So the area equals the length multiplied by the width. Now, typically, and I'm going to use just an A for area, since our length is a polynomial, I'm actually going to write it in parentheses x squared plus 3x plus 2. And our width, I'm going to write as the 4. And I could put it behind right here, but because I think it's a little easier to work with in front, I'm going to put it in the front. And now we're distributing. So we're taking 4 times x squared. So our area would equal 4x to the second plus, and then we're taking 4 times 3x. So that would give us 12x plus, and then we're taking 4 times 2, which is 8. So once again, notice that I have 3 terms in my polynomial, 3 terms in my answer. I do not have like terms. So 4x squared plus 12x plus 8 would be the area. If you'll turn your papers over, we'll continue on with the back side. So on this back side, we have 2 more problems where we are distributing a monomial factor. So I have negative 4x to the x and then y to the 4th. And so I'm going to be multiplying it by this polynomial, which has 3 terms. So negative 4x, y to the 4th. First of all, multiplied by the 7, y to the 2nd. Then I'll put a plus sign. I'll come back to my monomial, negative 4x, y to the 4th. It's multiplied this time by negative 2x to the 5th. And then plus, come back to my negative 4x, y to the 4th. And this time multiplied by 9. So when we multiply, we take those coefficients. So negative 4 times 7, that's negative 28. I have an x, and then on my y's, I will keep the base y and add my exponents. 4 plus 2 would give me 6. Then I have my plus sign. I'm taking a negative times a negative, negative 4 times negative 2. That would be 8. This time my x, I have a 1 and a 5. That I'll be keeping my base x, adding my exponent to get x to the 6th, and then I have y to the 4th. Now, normally I would write a plus sign, so I'm going to go ahead and do that. But then I'll notice that I have a negative times a positive. So I'm going to go ahead and erase the plus sign because a negative times a positive is negative. 4 times 9 makes 36, so negative 36. I have an x and I have a y to the 4th with that term. I look at my, I look at my terms and I have no terms where they have the exact same variables with the exact same exponents. So this would be my simplified final answer. And then our last example, I have the monomial negative 6a to the 6th b, and it is multiplied into this binomial, into a 2-term expression. So I'll start off with negative 6a to the 6th b, it is multiplied by, first of all, 3, a to the 5th, b to the 3rd, and then plus, and then I'll go back to my monomial, which was negative 6, a to the 6th, b, and this time it is distributed to negative 9, b to the 2nd. So notice that I had 2 terms, and so I've got 1, 2 terms in my multiplication. So I'm taking negative 6 times 3. That gives me negative 18. I have my a. I have a 6 and a 5, so I'll keep my base of a, add those exponents to get 11. For my b, I'll keep my base b. I have a 1 and a 3, so that will add to give me 4. Now I have a negative times a negative, so that will be a positive, and that's 54. 6 times 9. I have an a to the 6th power. B, I'll keep my base b. I have a 1 and a 2 to give me b to the 3rd. And so this is your example set for multiplying monomials and polynomials. Continue to ask questions as you have them.